What an Experimental Proof Means by Francis T.S. Mr. J over psi, please tell us what an experimental proof means. Since every physical experiment must produce a consequence of physical reality from a multitude of possible outcomes, for which we see that a single experimental test cannot prove whether a fundamental principle under test is correct. Since the complexity of our universe increases with time, a number of possible consequences also increases, as can be seen in Figure 1. But our universe is a one physical consequence dynamic universe, for which every physical activity can only give rise to a unique consequences from several possible consequences, like the dynamics of ourselves, for which it is the one physical consequent test result to interpret the principle under test of this talk. For example, such as the paradox of Schrödinger's half-life cat. Since every physical consequence from our universe has only one physical reality, a physical paradox cannot exist within our time-space, yet mathematics can, which is exactly why paradox and physical reality are mutually exclusive. In other words, paradoxes cannot exist in science, but for mathematics it can, since mathematics does not need to obey the laws of nature. A single experiment is not a sufficient test. Every principle needs an experimental test, but every physical test must converge to a unique consequence from multiple possible consequences, of which one experimental test is not adequate to verify an analytic principle under test is correct. Schrödinger is one of the greatest conspirators in quantum physics. It is hard to believe that quantum physicists took it so seriously. For example, Schrödinger's half-life cat is a created hypothesis, since this paradox cannot exist in physical reality. Nevertheless, from the experimental point, we see that sooner or later his cat will be dead, since the physical experiment must correspond to reality, from which I cannot understand how one can accept that his hypothesis is correct, even though test results contradict the non-paradox reality. For example, if the same setup are performed for many times, he is still able to pull out a death or alive cat from the box, from which we see that an experimental test unable to justify his theory, since every test must correspond to a physical reality. However, if Schrödinger had waited over weeks, very likely his cat will certainly be dead. Our universe is a dynamic, expanding space. Its energy degrades with time. Our universe is a dynamic, consequential time-space. Every experimental test is burdened to respond. Since entropy increases with time due to the dynamic expansion of our universe, any response of a test is a consequence of a number of possible responses. That is the law of entropy, from which every test must emerge from a consequence by the law of temporal, that is, t greater than 0, but may not be the result of the experiment's assumption. For example, such as searching for Dirac's antimatter, as shown in the next slide, Figure 2. Firstly, it is impossible to find an antiparticle in a null area since it is not even a space. Yet the burden of every test must respond by the law of entropy, since an experimental test is a physical thing that must change with time. Our universe has one and only one consequence. Figure 2 shows our universe is an energy-conserved, dynamic, expanding, isolated subspace where its boundary expands at the speed of light, for which it is impossible to harbor substance in a null region. Notice that any substance within our universe coexists with the same time with our universe. For example, a particle of 14 billion light years ago, if it did not decay, that is, due to increase in entropy, is the same particle at the current moment that had existed 14 billion light years ago. Similarly, currently I am not the same as 50 years ago, since all my physical aspects have changed. Figure 2 shows an expanding universe, a two-dimensional representation, only one physical reality. Inclined consequence. Since our universe is an energy conservation dynamic subspace, each consequential reality is governed by the law of entropy, which means that every emerging consequence is statistically inclined toward a favorable consequence, as can be illustrated in Figure 3. For simplicity, I assumed a wandering dice without dynamic expansion over bounded space. The one dot is facing up at time t equal 1, t1, in which the next favorable facing up dice is 2, 3, 4, or 5 dot, and 6 dot is the less favorable one. Although 6 facing up is the most unlikely one, but it did occur by chance, by which the next favorable consequence would again is 2, 3, 4, or 5 dot up. Figure 3 shows an example of a dynamic consequence time space, which shows an energy-conserved expanding dice. I assume the shape of the dice is unchanged for simplicity. Ohm's law. Since Ohm's law was developed from a time-spatially invariant system, that is, a timeless paradigm, it is a good example to show a mathematical theory to be experimentally proven as depicted in Figure 4. Even though an applied voltage V is assumed constant, but the value of R is a physical substance that changes by current I with time, in which we see that every experimental test must obey laws of nature. Nevertheless, the response, I, that is the current, changes with the changes of R, the resistance. In other words, every experiment must respond, but its response is by no means proof that Ohm's theory is correct. For example, how can the current I flow instantly or even before the application of voltage V? Similarly, how can a particle exist even before the birth of our universe? Why a single experimental test is not adequate to prove a fundamental law of physics under tests. Are our fundamental principles being wrong, or experimental test is incorrect? For example, if we use a temporal universe, that is t greater than 0, laws to obey, I'm sure Dirac anti-model doctrine may not be accepted. Reference 1. M. Thomson, Modern Particle Physics. Figure 4 shows a battery, a voltage V that is to be connected with a resistor R. Is a J divided by psi particle physically real? Our universe is an energy conservation dynamics expanding subspace. Is it possible to harbor antimatter or a piece of billion rock that's 2 billion light years old? If it does, this old rock must be a currently rock, otherwise it cannot be existed currently within our dynamic universe. For example, you are a current physical consequence of yourself, but not a 20-year-old of yourself. In fact, you're not even a fraction of a second ago of your reality. From which we see that a time is an illusion, as many physicists claimed. Since experiments have confirmed that antimatter J divided by psi does not exist within our universe, reference 2, but this antimatter is supposed to exist in the past time regime, even though it violates energy conservation laws of our universe. Even though their experimental proofs were physical, they are by no means correct. And this is just one of many examples shown that experimental proof provides a truth result, since experiments must respond regardless the right or wrong result. The fact that antimatter exists in the past time domain violates the law of energy conservation. Reference to S.C.C. Ting, Discovery Story in Adventure. Where is antimatter located? With reference to the preceding slide, antiparticle is supposed to be in a negative time domain of a zero-sum universe model, which is essentially the same model of Einstein's 4D spacetime as depicted in Figure 5. But zero-sum universe model contradicts with our energy conservation law. Secondly, zero-sum paradigm violates the law of entropy, since entropy increases with time. The irony is that this is the zero-sum model used by many prestigious astrophysicists that contradict the energy conservation of our universe. Otherwise, energy will not be degrading due to entropy increasing with time. Nevertheless, from the temporal universe, that is t greater than the 0 time standpoint, the J divided by psi particle is supposedly located in a negative time space, which is a null region. It cannot be called a subspace as depicted in Figure 5, which is a non-physically realizable model that violates all the laws of nature, in which we see that, without a set of viable, physically realizable laws for reference, fictitious mathematical sciences emerge which have no way to stop, since the origin of our science was developed from an empty space paradigm. The evidences are clear, as I refer to all the prestigious scientific journals to find out. Figure 5 shows a zero-sum universe model that was commonly used by astrophysicists. The Li-Yang predicament. One predicament in physics Nobel Prize history must be the Li-Yang permutation for which they fought for decades. Reference 3. Aside from their unreasonable mathematical gimmick, it must be the experimental test done by Wu I am questioning. Since mathematics theory is virtual, but experimental test is physically real. This by no means a response from an experimental test is sufficient to prove that their mathematical gimmick is physically real. Since Wu's experiment is physically real, it must respond within the laws of physics, laws of nature. From her test, she claimed that the universe, by a margin of roughly 1 and 10,000, did prefer left instead of right-handed particles. But our universe is an energy-conserved dynamic subspace that is temporal t greater than 0, which is a one-sided time model. My question is, why it will prefer left instead of right? In other words, our universe cannot accommodate any physical substance of the past. For example, a billion years old rock is a current moment of that piece of old rock, but not the past image of that rock. Since every physical test must have a physical response, that is a consequence, Wu's experiment was by no means proven that Li-Yang's theory is truth, but it was a physical consequence that she had gotten. Like Schrödinger's cat, one of the possible consequences, but not restricted to life or death of the cat, since there are numbers of possible causes to kill or not to kill his cat. Moreover, Li-Yang's theory, like the Dirac equation, was derived on an empty space paradigm, for which, as I see it, it must be a fantasized mathematical gimmick, as most of the current modern physics. Reference 3, T.D. Lee and C.N. Yang, A Question of Parity Conservation in Weak Interactions. Essence of Fundamental Principles. Without a set of physically realizable principles as a guide, it is anticipated that experimental physicists would not be able to determine that their test outcome is within the bound of a physically realizable regime or not. For example, to search for an antiparticle that exists in the negative time regime or substance of yesterday, since our universe can harbor only at the current instant of time, that is t equals 0. Since the birth of modern physics were mostly created to Einstein's relativity mechanics and Schrödinger's quantum mechanics at the turn of the 20th century, but they were mathematically created that violated all the laws of nature. This must be owed to the root where our mathematical science started from. Surprisingly, it was started from an empty subspace where our fundamental laws and principles were developed, from which we see that without a set of reliable laws and principles, it can easily fool us. Without the bound or criteria, many experimental tests were wrong, of which I have presented a couple of examples. Since an experimental setup is a physically substance, every response is a consequence of physical reality, regardless you want it or not. This is due to increasing entropy, that is, work done, of our universe that cannot be avoided. Nevertheless, if we have a set of viable laws to hold and check on every experimental test, erroneous data can be avoided. For example, how can we accept the yesterday of myself as existing today by viewing my own photo? Conclusion. Since mathematics is virtual and man-made, it does not need to obey the laws of nature, that is, temporal t greater than 0, such as the law of energy conservation, law of entropy, and others. Yet mathematics is not science, although science is mathematics. For example, it is not how beautiful a scientific equation is, but it is the physical realizability of the law that counts. For example, please tell me how beautiful Einstein's time dilation equation is as given by equation shown, the function of a delta t divided by 1 minus the quantity v over c squared, the square root of that. But beauty of this equation does not make dreams come true. Even to this day, physicists still cannot believe that Einstein's universe was created. Nevertheless, I have shown experimental proof can easily mislead us from physical reality. For example, such as the discovery of J divided by psi particle and Yang Li's work, which are examples that experimental proof can mislead to the truth of science. Nevertheless, burden of experimental proof cannot offer the truth of physical reality, since a physical response does not tell a correct answer. For example, how can we justify antimatter or a piece of billion light years old matter without any transformation to its current existence? Since science is a mathematical, symbolic language speaking for the truth, but there is a serious problem since we had treated mathematics as a science. Without this change, I do not believe our fundamental physicists can set free from mathematically oriented physicists, of which I have a newly published book on the Introduction to Physically Realizable Physics to recommend to you. Thank you.